So in this video we are going to analyze how to define the potential and how to define the difference in potential between 2 points. So we have said that if you bring a charge q0 from the infinity to the point where it's at the distance r from the charge q from the source, the potential energy of the system is this amount. You storage this amount of energy. So we define the potential, not the potential energy. This is the potential energy. We define the potential V of R. Like if you see, you can write the potential energy as kq divided by R by q naught. So the potential is the potential energy, everything divided by q naught. So the potential is kq divided by R. So we can say that of course, here there is a note to say that at the infinity, the value of the potential of this point at the infinity is zero. Is zero because we have taken the potential energy, the equation of the potential energy based on this fact. So the potential is defined like this. And how is defined the difference in potential? So it's also the same idea. Imagine that you have the working going from A to B. If the force is the electrical force, the force will be Q0 by E. So the Q0 by E will be minus the change in the potential energy, minus the change final minus initial, but minus the change will be initial minus final. So the small work will be F scalar ddr. And F scalar ddr is Q0 E scalar ddr. And this is minus ddep. So we can write the equation like this. So let's go to write the equation like this. And we define again the potential ddv as ddep divided by q naught. So I will have here E scalar ddr equal minus ddp divided by q0. And this is minus ddv. So as a conclusion, we define the change in potential equal minus E scalar ddr. Or if you want, the change in potential equal minus Ex ddx plus Ey ddy plus Ez ddz. And what will be the potential? The potential, it will be to integrate between 2 points. So the integral between A and V of ddv will be V sub B minus V sub A. V sub B minus V sub A will be minus the integral of E scalar ddr. These things. So the difference in potential delta V will be the minus the integral from A to V of E scalar ddr minus the integral of E scalar ddr. So what is the idea of the potential? The idea of the potential is that we want to get rid of forces, of vectors, and we want to substitute the idea of forces by the idea of potential energy and from the idea of potential. So imagine if I know ddv, what is the ddv? ddv, you see this equation. ddv is a function. So ddv is a function of x, y, and z. So ddv is the derivative of v respect to x ddx plus the derivative of v respect to y ddy plus the derivative of v respect to z ddc, and this is equal minus ax dx plus ey dy, etc., plus ez dz. So, watching this equation, I'm paying attention that what is multiplied by d dx is the ex, and what is multiplied by the d dx is the d dv, the derivative of v respect to s. You have that ex is minus the derivative of v respect to x. So what happens that if you find the potential, the slope, the negative slope of the function will be the electrical field. So knowing the potential, you know the electrical field. So y is minus the derivative of v respect to y, and z is minus the derivative of v respect to z. We will practice this idea in the following examples. Well, of course, the potential, because the potential is the potential energy per unit of charge. Well, the potential is measuring joules per coulomb. And this is named as volt. So 1 volt, so you can write this equation. The difference in potential is the difference in potential energy per unit of charge. So the difference in potential between 2 points, let's say the infinity and the final point, where is at the point R, is Q naught, the charge that you bring, by the change in potential.